In this topic, we discuss rational exponents. As we'll soon discover, rational exponents are directly related to radicals. Let's begin, though, with just a quick review of exponential expressions. Let's take, for example, 4 raised to the second power. This is an exponential expression with the base and the exponent. 4 raised to the second power means 2 factors of 4 multiplied times each other. The 2 designates the number of factors we are multiplying. And 4 times 4 is simply 16, so we say that 4 squared is 16. We can also look at the exponential expression 4 to the negative third power. We've also dealt with negative exponents before. Negative exponents simply are positive exponents in disguise. The negative sign tells us that we have to invert our base. So 4 to the negative 3 is simply 1 over 4 raised to the third power. And we know what 4 to the third power is. It's 3 factors of 4 being multiplied. And so 4 to the negative 3 is equivalent to 1 over 64. And we've also discussed 0 powers. Any number to the 0th power other than 0 is simply 1. So far we've dealt with exponents that are positive integers, negative integers, and 0. Well, in this lesson, we are going to deal with exponents that are fractions, rational numbers. Hence the topic, rational exponents. That is, let me restate, a rational exponent is an exponent that happens to be a fraction. Now, how do we simplify something like 4 raised to the 1/2? Well, that's what we're going to now talk about. So let's actually investigate rational exponents by looking at an example. Let's use the rules that we know pertaining to exponents to simplify the expression 25 raised to the 1/2 power. First of all, I want to state that 25 raised to the 1/2 power does not mean 25 times 1/2. Recall, exponents count the number of factors. So this is not a multiplication. An exponent of 1/2 does not mean multiply by 1/2. Okay, so what does 25 to the 1/2 mean? Well, let's break it down and think of 25 as 5 squared and then apply exponent rules that we're familiar with. Note, 25 to the 1/2 is equivalent to 5 squared raised to the 1/2 power, because 25 is 5 squared, right? Now, the rules for exponents tell us that when we have a power raised to a power, we multiply those powers. So what we have is 5 raised to the product of 2 times 1/2. 2 times 1/2 we know is just 1. And so this is the same thing as saying 5 raised to the first power, or 5. Therefore, that means that 25 to the 1/2 is equal to 5. 25 raised to the 1/2 power equals the number 5. Oh, do you see a connection? If I have the square root of 25, that's also equal to 5. Fractional exponents directly relate to radicals or roots. Let's take a look at the actual definition. So let's now take a look at the definition of rational exponents. If m and n are positive integers, and the nth root of a is a real number, then a raised to the fractional exponent m divided by n is the same thing as taking the nth root of a raised to the nth power, or the nth root of a all being raised to the mth power. Let me look at this example. Suppose I have 4 raised to the 3/2 power. Well, by the definition, the n, the denominator, becomes our root. So this 4 raised to the 3/2 would be equivalent to the square root, or the second root of 4 raised to the 3rd power, which is the same thing as taking the square root of 4 and raising it all to the 3rd power. Those are equivalent expressions. Now, how do you remember this? Well, the way I think of it is I like to think of the exponent here, this fraction, kind of like a tree. We know that on a tree, the bottom part of the tree is your root, right? You don't have the roots on the top of the tree. The roots are on the bottom part of the tree. So the 2 becomes your root, in this case, the square root. And the top number, well, that's your power. That's the number that stays on top. That's your power. In this particular example, remember, we have the square root, so you could also view it. Some of you might be thinking, well, you don't always have to write that 2, and that's correct. This 2 is equivalent to just the square root. These two expressions are the same, and similarly, this expression would be the same. However, if this was any number besides a 2, you would have to include that as part of your radical. Let's take a look at some examples where we actually convert back and forth between radicals and roots.